Hi, this is Chris and welcome to my IoT video. Apologies for any background noise that you could hear, it's just a car going past the window. So the project includes a PIR motion sensor, a embed, a Raspberry Pi and a Raspberry Pi camera module. The PIR is connected to the embed and that detects movement. When movement is detected, the embed will then send a signal via a serial cable or connection to the Raspberry Pi, which will then in turn the video camera on and start recording a video feed. This video feed will last anywhere between 30 seconds and a minute. It can easily be changed. My initial plan was to have the Raspberry Pi stream the video feed live over the internet for then a user to view on a web page. However, I found out the hard way that that's probably impossible to do because the bitrate will be too high. So instead what I'm going to do is the video feed is then saved on the Pi's SD card, and then I implemented a cron scheduling script which will upload all of the files in a certain directory, which is the recordings directory, to a public folder on Raptor. This will be done once every hour, so then everything that's recorded within an hour will then be put onto the public folder. And once the Pi has uploaded all of the recordings to the public folder, another script is then scheduled to run, which will then empty out the recordings folder on the Pi. This is then to prevent the Pi from running out of storage for future recordings. So if I now plug the USB cable connecting the embed to my laptop in, we can see the embed boots up. So I read online that it takes roughly about 60 seconds for the PIR sensor to warm up. If you don't let it warm up and you just go straight into trying to detect motion, it will actually give false negatives or false positives. So the best way to do it, I've seen, is to just do a for loop and inside the loop wait 1 second. Doing this for about 60 seconds, this just then gets the PIR sensor to a good state where it's ready to detect motion. So I'll start recording again when the PIR has warmed up. Okay, so now the red light is off. We can see that the PIR is now in a good state of detecting. So the script that's running on the Raspberry Pi is just a simple Python script, and as you can see with the blinking cursor, it's just waiting for input to be sent from the embed. So at the moment it's just in a constant state of checking the serial connection, checking if anything's being sent. If nothing's being sent, it's just going to keep checking. So now hopefully, if I put my hand in front of the PIR sensor, a red light should flag on the embed and the camera should start rolling on the Pi. So let's try it out. Brilliant. And as you can see, the camera has started rolling. If I put my hand in front of it, there we go. So this will now start recording for 30 seconds. It can be changed, but just for the moment I've set it to 30. So what this is doing, it's recording a video feed that is then stored in the recordings folder on the Pi. So I'll quickly change to the folder and I'll show you that now. Okay, so here is the recordings folder, and as you can see we have a list of video files. The name of the file is actually the timestamp that it was recorded. This is so that when they're actually uploaded to the public folder and displayed on a web page, it's just easy for the user to determine which recording happened in what order. So as you can see here, this one is the one that we just recorded, 2016, 11, 17, 2353, and the file is a .h264 file. So here is the cron table file. This is just a list of the cron jobs on the Raspberry Pi. The first line is the actual scheduler. This is the script that uploads all of the files in the recordings directory on the Pi to the recordings directory on the public folder. Both are scheduled to run every hour. The second schedule is the cleanup script. This script is designed then to empty out the recordings folder on the Pi to free up memory for later recordings. So now I'll show you, because they're both designed to execute on the hour, I'll manually execute them for you and then I'll show you the resulting So now I will manually execute the scheduler.sh file just to show you the files being uploaded onto the public folder. I'll then manually execute the cleanup script to show you the Pi's recording folder being emptied. I'll then run through all of the code for you. So now I'm in the shell folder. This is how you would execute the scheduler command by hand. Obviously the Cron-Job will take care of this and do it automatically once every hour, but just for testing purposes, this is how you do it manually. So now hopefully if I press enter, it will start automatically uploading all of the files in the folder to the public HTML folder. So if I press enter now, you can see that that started. So started scheduling between the Raspberry Pi and that's me on Raptor. It then gives a timestamp. That string there is then logged into the scheduler log file. That's then just for reference. So you can see now that it started to log the first file in the folder, which is of that name. And then it just gives a percentage completed, so in about 30 seconds that file will be done, and then it will move on to the next one. So I'll come back when all of the files have finished uploading. Okay, so now the scheduling has finished. So here it uploaded the 4 files in the folder, and they were all 100% successful, taking roughly 7 minutes to upload all of them. So now I'll show you my folder on Raptor to where they were uploaded. So I'll see you there. Okay, so now I'm on my laptop on Putty and I'm logged into my Raptor account. So here is the folder that I'm actually saving the recordings to. It's public HTML, third year IoT recordings. This folder is just going to hold the recordings, and then in the visualization section in A5, there'll be a PHP script that actually iterates through all of the files in the recordings folder and then outputs those to the web page. So now if I do ls to list all of the contents, you can see here that all of the files are successfully inside the folder. So that's those there. So yeah, so that scheduling script is due to run on the hour every hour. That will then just input all of the files automatically from the Pi to the recordings folder on Raptor. So now I'll show you the cleanup script running and removing all of the files from the Pi. Okay, so back on the Pi now. You can see we're in files-python-recordings. This is where all of the recordings will be saved from the camera once recording starts. So as you can see here, we have the 4 files that were just uploaded to Raptor. So now I will quickly run the cleanup command and then show you the contents of the recording folder again, and hopefully it should be empty. So then back in the shell folder, this is the command to manually run the cleanup script. The script has to be run as sudo because you're actually removing files from a folder, but that's easy enough to implement for the scheduling in the cron jobs. So now if I press enter, yep, so that's successfully hopefully removed all the files from the recordings folder. So I'll check back now and show you the contents. So now we're back in the recordings folder. So simply by doing the ls command, it should list all of the contents, and all of the contents have successfully been deleted. So now this is an effective way to upload all of the recordings to Raptor and then remove all of the recordings locally from the Pi, thus saving storage. So now I will run through the embed code and the Python code. Okay, so this is the code that's running on the embed. We've got the standard embed.h file and the standard C12832.h header file, which is used for the embed screen module. I'm then defining 2 variables, high and low, high being 1 and low being 0. These 2 values are used to determine whether or not the PIR is detecting motion or not. PIR will be equal to high when motion is detected and will be equal to low when motion has finished, or no motion is being detected currently. Device token is then set as 13. This is the start of the security measure that I put in place. So the embed has a device token of 13. The Raspberry Pi will have a device receive token of 13 as well. The embed will then encrypt its device token and send the encrypted token to the Pi. The Pi will then decrypt that token, and hopefully, if the decrypted token matches up with its device receive token, then it knows that the device that is communicating with it is its correct partner, and therefore to start the video feed. If the decrypted device token is anything other than the Raspberry Pi's device receive token, it will know that the device that it's communicating with is not its correct partner, so to not start the video feed. So the next bit of code are just the digital ins, outs, and serial communications between the embed. So the first is the PIR, the second is the LED, which is turned on and off to let the user know visually if motion is detected. Next is the screen module, which has some useful information output, and then lastly is the Pi. So next is the constant in calibration time, which is set to 60. This is the calibration time used by the embed to let the PIR warm up. Next is the Boolean value lock low. This is used to help maintain the detection flow in the main loop. It basically just helps determine when to start checking for motion again after motion has finished being detected. Next is the embed's public key, which is used to encrypt its device token. And next is the toCipherText method. This takes in the plain text device token and encrypts it using a RSA implementation. Next we have the setup function. This sets the baud rate between the embed and the Pi at 9600. It will then output a message to the screen saying that the sensor is being calibrated. It will take a moment. It will then loop for n number of seconds, n being the calibration time, which is 60 in this case. Each loop it will update the text on the screen, letting the user know what pass it currently is at. It will then wait for a second and keep going around until the calibration time has finished. It will then output a message to the screen initially saying calibration done, sensor active. It will then turn the LED off, visually letting the user know that the sensor is ready, and then it will wait for half a second. Okay, so this is the top part of the main method. We straight away call the setup method, which will set up the embed. We then clear the screen from the confirmation message that the setup method wrote. We then enter the infinite while loop. We set the screen cursor to 0, 0. We then check if the PIR is equal to high. This means that motion has been detected. We then straight away check if lock low equals true. If it is true, it means that we can proceed with the code inside the if statement. If it's false, it means that we need to wait for it to be set true again, and this only happens when PIR is equal to low, meaning that motion has finished. So inside this if statement, we then set lock low to false. We then output to the screen saying that motion has detected. We then send to the Pi the encrypted device token. We then turn the LED on the embed board, letting the user know that motion has been detected, and we then wait for 50 milliseconds. So then in the bottom half of the main loop, all we then do is check for when the PIR is equal to low, meaning the motion has finished. When this happens, we then check if lock low is equal to false. This means that we are now ready to start redetecting motion again, so then we set lock low to true. We then turn the LED off, telling the user that motion has finished, and then we wait for another 50 milliseconds. Okay, so this is the code that's then running on the Raspberry Pi. We're importing the serial module, which is used for serial communication between the Pi and the embed. From the time module, we're importing sleep. This is so that when the camera starts, we can sleep for an n number of seconds. From the camera module, we're importing the Pi camera class, and we're importing the math module as well. So next we have the private key and the token. This is obviously used so the Pi can check if the device it's communicating with is the correct one or not. We then have a value movement, which will be set to true when the PIR detects motion. We then have a record time, which is at the moment set to 20. However, the final implementation will be between 30 and 60 seconds. This determines how long each recording will be. Next we have the serial communication definition. We have the port, which is the default port for the Pi. We have the baud rate, which is the same baud rate the embed is set at. And then the parity, stop bit, byte size and timeout are all default. Next we're setting a value camera to the Pi camera object. Next we have the function, which decodes the ciphertext sent from the embed into plain text, which will later then be compared to the token up there to check whether or not the device the Pi is communicating with is the correct one. So now we enter the file's infinite loop. The first thing it will always do in the loop is checking the input from the serial communication. The if statement is basically if the input does not equal nothing. So in general operation, when no movement is detected, nothing will actually be sent to the Pi. The embed doesn't send anything normally. It will only send something when motion is detected. So this statement here, this if statement, will only be triggered when something is sent to the Pi. Now we don't know what that something is. We know that it's going to be a string of some sorts, but now it's our job to decode it to determine whether or not the device that sent it is the correct device or not. So now it will actually print the device token out that was received onto the screen. It will then convert the token that was received into plain text, and then it will check if the plain text is equal to the token. If the two are equal, we know that the device that sent it is the correct device, so we'll set movement to true. So then, while movement is true, we want to get the current timestamp. We then want to set up the string for the file name. We are then going to print out to the screen where we're going to save the file as. We're then going to start the camera preview, which is the preview on the TV, and then we're going to start the recording, setting the file destination as file name. We then sleep for n seconds, which in this case is record time. This ensures that then the recording is record time seconds long. We then stop the recording, stop the preview to the TV, and then we set movement to false, and then it goes back up to the top and it starts checking the input from the serial command line again. And then when we do eventually break out of the infinite loop, either via an exception or a keyboard interrupt, we then close the serial communication line. So this is the shell script for the scheduler. So all we're doing is outputting a string to the log file, which indicates that we're sending files from Raspberry Pi to Raptor and the timestamp there. The actual command itself to send the files is just secure copy. So it's just secure copy the folder location of the recordings, star, which means all of the files in that folder, and then the destination folder on Raptor, so CW509 Raptor :public third year IoT recordings. So that'll then do that for every single file. And then once all of the files have finished being sent, another string just to indicate that the scheduling has finished will be outputted to the log file as well. And this is the shell script for the cleanup file. So very, very simple. All it does is it just removes every single file from the recordings folder. Now it does have to be run as sudo, because otherwise it will give a prompt to ask whether or not you really want to remove the files. But that's easy enough to implement in the Cron-Job. So as of yet, I haven't implemented the communication with the MQTT server. However, that's my job tomorrow. So once I've done that, I'll make a recording and show you that as well. But apart from that, I think that should be everything. So I hope you enjoyed the video, and bye. So this is now a demonstration of the Pi communicating with an MQTT server. The MQTT server I've got is actually a local one that's installed on the Pi. This is because I'm working from home. So the subscription is Pi Recordings, and it's hosted on the local host. So now I will show you the Pi actually publishing to the subscription, and then I'll go through the code that does it. So this is the serial read script that I showed earlier on. Now with the addition of the sub-process call method here, this method is the method that is used to publish to a subscription. So the host is the local host, the topic is Pi Recordings, and the message I've set to time_date, which is the timestamp of the recording. This is then logged onto the MQTT server. So now with the serial read script running on the Pi, if I put my hand in front of the sensor like before, the sensor will trigger and the camera will start. However, now if I exit out of this manually with keyboard interrupt and I switch screens, you can see here this is the listener, the script published to the MQTT server. That is the timestamp that the recording took place.